Yes, good morning to all everyone. I'm Dr. Kameshwara Kumar, Associate Professor in CMRCET. In last sessions, we have discussed the topics for the two topics, partial differential equations and limit and continuity. Now, today the discussed topic, homogeneous functions as well as Euler's theorems. Okay, now the third unit, the homogeneous function and Euler's theorem. Now there is a multiple of the variables, that is a function. What is a homogeneous function? A function f of x comma y comma z, the function of the three variables x, y, z, is said to be a function of a degree, n in variables x comma y comma z. Now f of x is the replace of kx, y is the replace of ky, z is the replace of kz, is equal to k power of n of x, y, z. So k power of n f of the function of x, y, z. Here n is a real numbers. Okay, n is a real numbers. A homogeneous function of order n in x and y, of the two variables x and y, can be expressed as x power of n into f of y by x, or y power of n f of x, y, z, x by y. This is a homogeneous function f of x comma y comma z, three variables, is said to be a function of a degree n in the variables of the three variables x, y, z. If x is the replace of kx, y is the replace of ky, z is the replace of kz. Now we can represent k power of n. N is nothing but represent for the degree. Okay, f of x, y, z. Suppose the k square into f of the given function f of x, y, z. So that degree is nothing but 2. K power of 0 is nothing but degree is 0. So n is a real numbers. A homogeneous function of a order n in x and y variables can be expressed as x power of n f of y by x, or y power of n f of x by y. See the example of the homogeneous. Let the function of the two variables x comma y is equal to the given function x square plus y square. There are the two variables are there, x square plus y square, the given function. Now the function of kx comma ky is equal to, is x is a replace of kx whole square and y is a replace of ky, the given function x square plus y square. Now the k square x square plus k square y square. Now the k square will be common. Now x square plus y square. Now x square plus y square is the given function. Therefore, k square into f of x comma y. Therefore, if the given function f of x comma y is a homogeneous homogeneous function of degree is 2. So k square is nothing but is 2. So this is the example how to determination for the homogeneous function of a degree is 2. See another example, f of x comma y is equal, that is also two variables, 3xy by y plus log y by x, the given function of the two variables. Okay, now you can represent now f of kx comma ky, how to determination for the degree k power of n, 3kx by ky plus log ky by kx. So k will be cancelled, therefore k power of 0 into 3x by y plus log y by x. So therefore k power of 0 into the given function f of x comma y, so is 0. Therefore the function f of x comma y is a homogeneous function of degree is 0. Degree is 0, k power of 0, that is the homogeneous function, the given function. What is the function? 3x by y plus log y by x is the degree is 0. Okay, so on the next one, what is the Euler's theorem on homogeneous function? So what is the statement of Euler's theorem for the homogeneous functions? Okay, now the statement of the Euler's theorem, if z is equal, z is a one function, the difference of f of x comma y, that is the two variables x y, is a homogeneous function, of a degree n, then is a represent for x into dou z by dou x plus y into dou z by dou y equals n into z. So that is the Euler's theorem that z is a function f of x comma y is a homogeneous function of a degree n, then x into dou z by dou x plus y into dou z by dou y is equal to n for every x comma y in the domain of a function, So then this is the homogeneous of the Euler's theorem, x into dou z by dou x plus y into dou z by dou x is equal to n into z. N is a degree of n. Okay, z is nothing but the given function. Okay, this is the two variables. Note, if u is the another function is homogeneous of the three variables x, y and z. That is the three variables are there, x, y, z. U is a function of a degree n, then x into dou u by dou x plus y into dou u by dou y plus z into dou u by dou z equals n into u. So this is for Euler's theorem for homogeneous of the two variables and three variables. Okay, now the problems of the Euler's theorem. The first one, find x into dou u by dou x, u is a function, plus y into dou u by dou y, using Euler's theorem, for the functions. First one, u is equal to x cubed y cubed by x cubed plus y cubed. Now the second one, u is equal to x square plus y square by root x plus root y. Okay, and the third one, u is equal to y by x. So find the x into dou u by dou x plus y into dou u by dou y using the Euler's theorem. We can determine the three functions. So the first one, we can determine x cubed y cubed by x cubed plus y cubed. So now the function of u of kx comma ky. So here there is a two function, that is x and y. X is the replace of kx, y is the replace of ky. So that's why the k cubed x cubed plus, sorry, okay. Now k cubed x cubed into k cubed y cubed by k cubed x cubed plus k cubed x cubed. Now equals, the common is a k cubed x cubed plus y cubed by k power of 6 into x cubed y cubed by, yes, the k cubed is a common, x cubed plus y cubed. So now k cubed into x cubed y cubed by x cubed plus y cubed equals the k cubed into u of k cubed into u of x comma y. So here u of x comma y is a homogeneous function, of a degree is 3. Therefore, by Euler's theorem, x into dou u by dou x plus y into dou u by dou y is equal n into u. N is nothing but 3. 3 into u. That is the solution of the given function u is equal to x cubed y cubed by x cubed plus y cubed. Now the second one is similarly the same as u of x comma y. U is the variables of two variables x, y. X square y plus y square by root x plus root y. Okay. Now u of kx comma ky equals k square x square plus k square y square by root of kx plus root of ky. Now the k square is a common, x square plus y square by denominator. Root k is a common, that is the k power of 1 by 2 is the root x plus root y. So now k square into k power of minus 1 is like that, k power of 3 by 2. Now the x square plus y square by denomination root x plus root y. So here the k power of 3 by 2 into u of x comma y. The given function u of x comma y is like that, x square plus y square by root of x, root x into plus root y. Therefore, u of x comma y is a homogeneous of a function. Homogeneous of a function. Degree is s. What is the degree? Is 3 by 2. Therefore, by Euler's theorem, x into dou u by dou x plus y into dou u by dou y is equal to n into u. Here n is nothing but 3 by 2 into u. That is a solution for the second problem. Now, the third one is u is equal to y by x. U is nothing but now u of kx comma ky is equal to y by x. Y is nothing but ky by kx. K will be cancelled, that is the y by x. So that's why the k power of therefore u of x comma y is a homogeneous function of a degree is 0. Therefore, by Euler's theorem, x into dou u by dou x plus y into dou u by dou y is equal to n into u. N is nothing but 0. So the value 0 into u is nothing but 0. So this is for homogeneous functions of the Euler's theorem. And the next one is the another one is the verified Euler's theorem for the function z is equal to ax square plus 2hxy plus by square. So verify is nothing but we have to prove that Euler's theorem LHS equals RHS. Now the given function z equals ax square plus 2hxy plus by square. Now z of kx comma ky. Find out that of a degree a into a square x square plus 2h kx into ky plus b into k square y square. Now the common is nothing but k into k square. The k square is a common ax square plus 2hxy plus by square. So now the k square into the given function is z. Therefore, z is a function is homogeneous function of a degree is 2. Now by Euler's theorem, we have to show that the problem is verified by Euler's theorem is verified we have to show that x into dou u by dou x plus y into dou u by dou z is equal to n into u. So n into u, that is the 2u. Now is verified for Euler's theorem. X into dou u by dou x plus y into dou u by dou z is equal to u. So first of all, we can find out the dou u by dou x, and next one we can find out the dou u by dou y. We can find out the dou u by dou y, and the next one we can multiply for x into dou u by dou x plus adding for y into dou u by dou y. Now we can get the result. Okay, first of all we can find the now find out dou z by dou x. Now z is equal to, now the value is z is equal to ax square plus 2hxy plus by square. With respect to x, y is a constant, that is 2ax plus 2hy, that is equation 2. So with respect to x, y is a constant. So now dou z by dou y equals, with respect to y and x is a constant, 2hx plus 2by, that is equation 3. With respect to y, x is a constant. So now multiplying equation 2 by x and equation 3 by y and adding, we get, so equation 2 is multiple by x and equation 3 multiple by y and adding, therefore x into dou z by dou x plus y into dou z by dou y equals, so we can multiple equation 2 square plus 2hxy plus 2hxy plus 2by square and adding equation 2 and 3 and also multiple for x with respect to x, with respect to multiple by x and multiple by y, equation 3. Now we can get, so 2 is a common, ax square plus 2hxy plus by square. So now the 2 into the given problem from equation 1, the given problem is z is, therefore 2 into z. Therefore, hence the Euler's theorem is verified. So the verified for Euler's theorem is nothing but we have to prove that LHS equals RHS. So what is Euler's theorem? X into dou z by dou x plus y into dou z by dou y is equal to n into z. With the variables, the function is given for u. Obviously, x into dou z by x into dou u by dou x plus y into dou u by dou y is equal to n into u. Okay. And the next one, another one, we can verify Euler's theorem for the function u is equal to x square into tan inverse of y by x. Tan inverse of x form is 1 by 1 plus x square into dou x by dou x. Okay. Minus y square into tan inverse of x by y. And also prove that, and also prove that, and also prove that dou square u by dou x into dou y, second order partial derivative, x square minus y square by x square plus y square. First of all, we have verified of the given function u equals Afterwards, we have to prove that. Okay. Now the solution, we have u is equal to the given function x square tan inverse of y by x minus y square tan inverse of x by y. That is equation 1. So you observe is a clearly u is a homogeneous function. U is a homogeneous function of a degree is 2. Therefore, by Euler's theorem, we get what? Yes, what is the Euler's theorem? Is nothing but x into dou u by dou x plus y into dou u by dou z is equal to n into u. N into u. N is nothing but of a degree is 2. Therefore, 2 into u. That is equation 2. Then afterwards we can verifications. Okay. Now verification. Okay, differentiation. You can verify the Euler's theorem. Differentiation equation 1 partially with respect to x. We get dou u by dou x equals. So now you can divide x of uv form. Dou u into tan inverse of y by x plus x square into derivatives of tan inverse of x form 1 by 1 plus x square into dou u by dou x. So 1 by 1 plus y square by x square into dou by dou x of y by x, like that, minus y by x square. Okay, again with y square minus y square into again with respect to 1 plus x square by y square into 1 by y. Dou x by dou x is nothing but 1. Is 1 by y. With respect to x, y is a constant. Y is a constant. With respect to x, y is a constant. Now you can simplify. Therefore, 2x into tan inverse of y by x. Okay. Now we can get the LCM. Now x square will be cancelled. Now again you can apply for plus into minus x square y by x square plus y square in the denomination LCM. So minus y cubed by again LCM x square plus y square. Y will be cancelled, y into y square, like that, y cubed. Okay. Now 2x into tan inverse of y by x. Now the common is minus y is a common. X square plus y square by denominator same x square plus y square. So will be cancelled. X square plus y square by x square plus y square will be cancelled. Okay. Now dou u by dou x equals 2x into tan inverse of y by x. Okay. Minus y. That is the third equation. With partially with respect to x, now again get the result is dou u by dou x equals 2x into tan inverse of y by x minus y. Okay. Now partially with respect to y, equation 1, right? Differentiation. Equation 1 partially with respect to y, we get. So with respect to y, x is a constant. Now the dou u by dou y x square into again 1 by 1 plus y square by x square divided x of tan inverse y by x form into 1 by x minus 2y into tan inverse of x by y minus y square into 1 by 1 plus x square by y square into divided x of 1 by y is nothing but minus x into y square. So here with respect to y, the x is a constant, right? The x is a constant. Now we can get a simplified. Now the result is x cubed by x square plus y square minus 2y into tan inverse of x by y plus again simplification the LCM we can get the result x y square by x square plus y square. Now x is a common, x cubed by x square plus y square plus xy square by x square plus y square minus 2y into tan inverse of x by y. Now the result is minus 2y tan inverse of x by y plus x is a common, x square plus y square by x square plus y square. So will be cancelled. So now dou u by dou y equals. Now the result is minus 2y tan inverse of x by y plus x. That is the equation 4. Now multiplying equation 3 by x and equation 4 by y and adding then we get x into dou u by dou x plus y into dou u by dou y equals 2 into x square tan inverse of y by x minus xy minus 2y square tan inverse of x by y plus xy. So plus xy minus xy will be cancelled. 2 into x square tan inverse of y by x minus 2y square tan inverse of x by y. Therefore 2 into u. Therefore x into dou u by dou x plus y into dou u by dou y is equal to u. Okay, this is equation 5. Therefore from equations 2 and 5 we observe that Euler's theorem is verified. Okay. Now differentiation equation 4 again partially with respect to x, we get dou square u by dou x dou y is equal minus 2y into 1 by 1 plus x square by y square tan inverse of x. 1 by tan inverse of x formula plus 1. So now the result is minus 2y square by x square plus y square plus 1. So now the simplify x square minus y square by x square plus y square. Therefore, the result is through dou u by dou x is equal x square minus y square by x square plus y square. Okay, that is the solution. So in this section, we have to discuss the concept. What is the homogeneous of a degree n, and also we can find the Euler's theorem, how to determination for Euler's theorem, and now and also verification of the verify for the Euler's theorem. Okay, this is the concept of Euler's theorem for homogeneous of a degree. Okay, thank you everyone.